guys remember how to long divide? Let me show you. Remember you asked the question, how many times does 9 go into 8? And you'd say 0. And then you'd multiply, subtract, bring down. And then you'd keep repeating this process. And you would say, how many times does 9 go into 31? Only 3 times. And then you keep subtracting, bringing down. You have to learn this at some point. You guys can't lie to me. So I don't expect you to remember it, but that's how you long divide. Okay. Let's see that again. How many times does 12 go into 1? 0. How many times does 12 go into 15? 1. And you keep repeating the process until you've carried down the last thing. And this only goes in once. And we have a 6. So you could write your answer with a R6 here. That's a good response. Today we're going to write it with a fraction, basically saying that you have 6 left over out of the 12 we're dividing by. So this is really an accurate answer and most descriptive. Okay. So we've been talking about polynomials, and we've added them, we've multiplied them, we subtracted them, we factored them, and the last thing we need to do is divide them. Okay. So when I say dividend, hold on 1 second. Let me pull up the key here. The dividend is the number that's being divided. The divisor does the dividing, and the quotient is the answer. Okay. So if I take 90 divided by 9, I get 10. 10 is the quotient, it's the answer. It's the result. 9 is the divisor, and 90 is the dividend. So those numbers go, when we long divide, the dividend goes underneath, what you're dividing by goes out front, and the answer to the question is what's on top. Okay. So if I say 46 divided by 6 is 7, that means 6 is a factor of 42. And if I give you this, and I tell you that it's equal to this, which it is, that means that when someone divides the dividend evenly, that means that what you're dividing by, the divisor, x plus 3, is a factor of what you divided. It works the same with numbers, right? Those are 2 examples I just wrote. One of them with numbers, and one of them with polynomials. So let's just get to the chase. How does this work? What do you need to know? You need to look here and ask, what do I need to multiply 3x by to get 3x squared? X. So you put the x right above the term that you asked that question about. And then you multiply. And if you do it right, this will always cancel. And we get 15x with that double negative. And we bring down. We ask another question. How many times does 3x go into 15x? Or in other words, what's the answer to this question? Again, these numbers here kind of get dealt with, but it's the leading term that we care about the most when we ask the question. And the answer to this mystery multiplication is 5, positive 5. So I multiply, which I didn't really describe how you do that last time. You take the 5, you multiply it by the 3x, and you also distribute it to the minus 7. So that equals 15x minus 35. With a 0, that's perfect. It means we're done. So the answer to this is this. So if I want to write it all out in a sentence, it's this. Okay. And you might be asking, like, why is this even useful? Like, why are we dividing? Like, how does this even tell us anything about what we've been doing? Well, if you multiply both sides by the denominator, you get this. So we just figured out the mystery binomial factor that you need to multiply 3x minus 7 by to get the dividend, the quadratic. Okay, so it actually finds factors for us, but we got to know what one of them is first. You see? Okay. So, and that's really it. That's all I have to tell you today. And if that example made sense to you, you're probably good. But there's a little snag. There's always like one thing we got to remember. And if your dividend, what you're dividing, is missing terms, like there's no x squared, there's no x, you have to put placeholders in there. Because let me show you what happens if we don't. So you don't have to write this down. But if I just do this and I ask, oh, okay, x squared makes that work, blah, 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 blah. You continue. These don't even have the same, they're not even like terms. You can't even really combine them very well. I mean, you can. I guess it would be something like this. But it really just messes it up. So in order to keep things clean, if you're missing a power, a term with a degree, you put a 0 in there. And these are called placeholders. That's what that meant up there. So, question. X times what is x cubed? I'm looking right here. X squared. Multiply it out. And by the way, these are the same steps we did at the very beginning. Subtract. And you see how everything's nice and lined up, and I have my x squareds there, and then I see that I can add down. X times what is x squared? We're always looking at the first, just like we did here. We're looking at that first leading term when we ask these quote questions. So the answer to that multiplication is x. So it looks like we get, again, just x. Oh, I'm sorry, guys. If you notice that, this is a minus. I don't know why I wrote plus. Sorry about that. X times what is x? If we look right here. 1, right? Plus 1. Multiply that through, subtract, and we get a 0. So the answer is this. Okay. Which, if you kind of put all the pieces together, the purpose of doing this is we just figured out what I just wrote. The missing factor is what we just found, right? And it is a factor of x cubed minus 1, right? So this is kind of a nice, trying to line up the purpose of why we're doing this. we kind of find missing factors. Which is a process we probably would have came up completely empty-handed without me telling you this. Okay. All right, 2 more. So let's take a look. We are missing terms in here. You see, we're missing an x squared. So when I write this out, put my 0 in there. Okay. How many times, and we're just looking at the leading, how many times does x go into x cubed, or what's this? The answer to that is x squared. Multiply, which you're really distributing. You see, multiply, multiply. Subtract. Bring down. And look here. What do you multiply x by to get 4x squared? And the reason why I'm asking that is because that will cancel this. So when you figure out that the answer is 4x, and you put that up here, and we multiply, we get a double 4x squared, right? We get this, which allows us to continue with the division. Okay, so be careful with that. It's always, you're always subtracting, so there's always the chance of a double negative. Okay. How many times x times what is 3x? 3. Multiply and subtract. 0. Answer. Let's do one more. We're missing a constant term, so I'll go ahead and put a plus 0. Not always necessary to put the 0 at the end, but we'll do it just because we don't want to have any other special rules, so let's just do it every time. Question. We're here, and we always look at the leading. So x times what is x squared? X. Of course, we've answered that question about 4 times. Multiply. Multiply like this. Is minus 12x. And if that seems kind of a stretch, you can always on your calculator do this. Negative 16 minus 4. Cool. How many times does x go into this? So what do you multiply x by to get minus 12x? Minus 12. Okay. Multiply that through. Subtract. First part always cancels, you see, if we answer the question right. So the answer is remainder negative 48. But I don't want you to write that because it's just not informative. So what you do instead is if you have a number left, you do plus, and then you put that answer you got, and you divide it by what you're dividing by. This is also you could refer to this as the remainder. Okay, so this is the answer. Okay. Okay, So you've seen a question that has a remainder. You've seen ones that don't. Let's answer these questions as yes or no. Is x minus 4 a factor? Yes. It went in evenly. Is x minus 4 a factor of this? No. It did not go in evenly. We have a remainder. All right. There's plenty of practice here you can do. Answers are